Okay, right, welcome back everybody. We're going to look at practice test 22, 1H, higher. This is the non-calculate paper. Let's not waste any time. Number one. So here's a bias spinner, meaning it's not 25% each one, even though the diagram might make you think that, don't assume. And underneath it gives you all the probabilities of different colors. So what we'll notice first is there's no green. So to work that out, you need to add the three we know already. So add your red, add your yellow, add your purple together, 0.65, and take the answer away from 1. So 1 minus that. So 1, take away 0.65 is 0.35. The probability of getting a green is 0.35. Again, those numbers should all add up to 1. Now, that's not the question. It is going to help you, but that's not the question, so be really, really, really careful. The question asks, probably the spinner lands on red or yellow. Actually, we didn't even need to know green. Red and yellow you add these two together, right? So 0.25 plus 0.2, 0.45, right. Yeah, a little bit confusing there. I think the next bit is probably, this is really confusing. Question has nothing to do with green. Funnily enough, I wasted my time working out green. Sometimes that happens. Don't know why they left that blank there. So red or yellow, didn't need to know 0.35 whatsoever. Red and yellow, just double checking. Fair enough. Yang is going to spin the spinner 300 times. What's probably lands on purple? Right. Probably purple is 0.2. So you know the expected number of times that you get purple is your total number. We call this total number of trials. Think of trials as how many times am I doing this spin? The technical term is trials times your probability of purple, right? So we're multiplying together 300 is the total number of trials times the probably you get purple on any given trial 0.2. Now 0.2 is the same as 2/10. So the reason I write it this way is, well, we're not allowed a calculator. So you could do 300 divided by 10, which is 30, and then times it by 2, which is 60. 60 is your answer. So you'll get 1 mark for that working there. 1 mark for this, I guess, and then third one there. I think 3 is a bit generous here. Oh, I'm still scratching my head. Why leave the green one blank? Weird. Seeing as, yeah, it's just weird. Why would they leave that blank if at no point do we need this? Yeah, whatever. We move on. Okay, right, next up, number 2, we got expand. So times out your bracket, 3c cubed times c. Remember, if there's no power, you can put it 1 in its place. Add the powers, you get 3c to 4, followed by 3c cubed plus 4, times 4, which is 12c cubed. That's your answer. 3c4 plus 12c cubed. Well done. You get 1 mark for each one correct. Right, show this. 99% of questions, anytime they say show that, pretend you don't know what the answer is, right? I've crossed it out. I've totally forgotten what adding these fractions would give me. What I'm going to do at the end is I'm going to rub that out. And if I get the same answer, then I'm happy. And I've shown that. So 99% of the time, showing just means work it out, pretend you don't know the answer, and use the fact that we're giving you the answer as a good way of checking your answer at the end. Right, so usually if I was adding, I'd have to change these two to improper top-heavy fractions. So 2 times 3, 6. Add the 2 on top is 8/3 is the first one. Second fraction, 3 times 4, 12, plus the top number, 15 quarters. I want the common denominator. What's the lowest common multiple of 3 and 4? It's going to be 12. So we will rewrite both fractions to be out of 12, meaning I times the first one, top and bottom, by 4. That's going to be 8 times 4, 32 over 12. And the second one I will multiply by 3, meaning 45 over 12. Right, let's add this together. So 32 and 45, do a bit of working if you need to. 77. So 77 over 12. how many 12s go into that? Well, 72. Why have I got a feeling I've got this wrong again? Times 4. 8 times 4 is 32. Yeah. Yeah. So how many? Right. I want to write it as a mixed number again because I do remember it being as a mixed number. 12 go. I know that 12 times 6 is 72. So 12 goes into 7. 6 times remainder 5. So it's going to be 6 and 5/12. There we go. Lovely. And if it was a different number, I would have gone over it and checked it again, but I'm happy with that. I've got the same mixed number. There's no need to check. Number 4, solve the simultaneous equations. There's 2 ways. Do you know what? I'm going to try and get the same coefficient of y. So 5 and 3, 15 is the number we're going for. So I'm going to times this. I'm going to label this equation 1 and equation 2. To get my new equation 3, I'm going to multiply the first one by 3, because that way I will get 15y. So it becomes 9x, because that's 3x times 3, minus 15y times 3. And 3 lots of 25 is 75. Cool. Okay, now to get my other equation, I will multiply the second equation by 5, thus give me my fourth equation. 4 5s are 20x. 5 lots of 3 is 15y. And 5 lots of 14 is 70. So there is a temptation now to want to take away, but always remember this, right? The thing we're cancelling out are the y's, right? 1 is a positive 15y and 1 is a negative. Always remember the acronym STOP. STOP stands for same sign, take away, but when they're opposites, like in this case, we get to plus them. So stop because the signs are opposites. They're both 15y, but one's a positive, one's a negative. When that's the case, we add them, right? Because adding a positive and a negative together gives you 0, right? That's the whole point. So when I add them together, the idea is those y's, the 15y and the minus 15y, cancel out. All right, let's add together 9 and 20, 29x equals 75 and 70 is 145. Cool. So 29 lots of x equals 145. Oh, this is a tricky one. Now, clearly this is not going to be a whole number. Why is it that I feel like I've made a mistake somewhere? Here we go. So, no, I haven't made any mistakes. It's just awkward numbers is all. So, how many 29s going to 145? If you do need to sort of run a list here, feel free to do so. So 58. I'm doing my 29 times table. So it is 58 times 29. 187. Add another 29. 116. Add another 29. 145. Okay, so 1, 2, 3, 4, 5 times. Right, x is 5. Good start. Right. Next up, we got to work out y, right? So you get a choice of any of these 4. Go with whatever looks easiest. I like 2 just because there's no minus signs. So into my 4x plus 3y equals 14. Well, I know x is 5. So 4 lots of 5 plus 3y is 14. 20 plus 3y is 14. This is going to involve negatives. So 3y is 14. Take away 20. So 3y is negative 6. Y is negative 2. And we're done, right? X is 5 and y is negative 2. Very good. Number 5, factorize. We like a good factorize question. I don't want to go too far without having checked the answers because I hate, it's frustrating when I've sort of think I've got the answer and it isn't. Yeah, I can confirm the previous answer is correct. Okay, 5a, factorize. So remember team. Team stands for times for the end, add for the middle. Basically, what 2 numbers multiply to give negative 9, sorry, but add to give positive 8. Right, it's going to be the numbers 9 and 1 because you can time them to get 9, and you can make 8 by adding and subtracting. But which one's the negative? It's going to be the negative one. That's the negative, and the positive 9. That's the positive, because when you add these, you are still left with a positive number. So let's put this in double brackets. X plus 9, x minus 1. You can write x minus 1 first and then x plus 9, but the negative must be in front of the 1 and the positive must be in front of the 9. For example, if you said minus 9 in one of your brackets, that would be totally wrong. Now, part B, notice how both the left side is exactly the same as A, because they want you to put in brackets. Remember, this equation, think of the brackets as you're timesing two numbers. And you always get an answer of 0 when either of your brackets equals 0. So all you got to do is solve these two equations. Yes, there are two answers. And you're done. So I need to solve these two equations. Easy peasy, right? First bracket would be x negative 9. Second bracket, x is 1. Job is done, right? So the two answers, x is 1 and x is negative 9. Moving on. Simplify a to the power of 0, where a is a number greater than 0. Basically saying, look, a is a positive number. Any positive number to the power of 0 is 1. Always. 7. Right. Now, remember, this is the sort of default way of presenting any straight line graph, y equals mx plus c. Now, because it's so commonplace, the letter m is your gradient, or how steep your line is, followed by c, the y-intercept. Or in other words, where does your curve cross the y-axis? We'll start easy, right? It crosses the y-axis at negative 1, so c is negative 1. That's the easy one. Now, to get the gradient, pick any 2 points on your line. Ideally, any 2 points where the numbers are really easy to read. For example, 2, 2 is going to be way better than picking some random point like there, because, what number even is that? So I'm going to pick any 2 points, preferably ones where it's easy to read. There we go. So I pick the points 2, 2 and 4, 5. Gradient is rise over run, right? So gradient, we always say rise over run. Now, the formal way is just to say the difference in y coordinates over the difference in x coordinates. This is probably a bit overkill, but some questions you will not get the luxury of a diagram this fancy, so be prepared, right? Sometimes they could easily ask you this question by simply giving you 2 coordinates, so be ready. All right. Anyway, because it's a slightly easier version, you know what? I'm just going to go rise over 1. Right, so the difference in y coordinates would have been 5 take away 2, which has a height of 3. Over your difference in x coordinates, 4 take away 2 is 2, is your width. So rise over 1, 3 over 2 is your gradient m. So in other words, we want to leave it in the form they asked for. We've got y equals 3 over 2 n minus 1. Now, you can write the gradient as 1.5. Whether you left as an improper fraction. Why did I write m earlier? That would have lost me a mark there. My bad. It should be 3 over 2x or 1.5x take away 1. But that is the answer. Expand and simplify double brackets. So, I don't want to annotate this. Any double brackets, pick any pair of brackets to begin with. I'm going with this pair first. I'm just going to expand this double bracket. Let's deal with 3x plus 1 later. But right now, I'm just doing this how I usually would, right? Double brackets. 3x times x, 3x squared. 3x times 2 plus 6x. Minus 1 times x, minus x. And minus 1 times 2, minus 2. Tidy up the middle two terms, so you get 3x squared plus 5x minus 2. Happy days. Let's wrap some brackets around it. So basically, this bit here is the same as 3x squared plus 5x minus 2. We still, however, need to multiply it by 3x plus 1. So let's do that. So be careful here, because we're going to multiply all three terms by 3x. So do you know what? Let me choose a different color just to be clear. I'm going to switch it up. Let's go red. 3x squared times 3x is 9x cubed. 3x times 5x times 3x is plus 15x squared. And minus 2 times 3x is negative 6x. Switch it up with, I'm going to times those three terms again now, but by the 1. So that would be plus 3x squared. That would be plus 5x. That would be minus 2. And, right, all I got to do now is simplify. So look, that's my only cubic term. So 9x cubed stays put. My x squared terms, which are 15 plus 3, that's plus 18x squared. My minus 6 and my plus 5, that's minus x or minus 1x. It's better to write minus x. And then my minus 2 at the end, my linear term. So let me just double check the mark scheme. I'm pretty confident about this, but you never know. 9, yeah, perfect. I got it spot on. It's good. Now, if you did write these in sort of different order, that's fine. So what I mean by that is that if you wrote 18x squared plus 9x cubed, minus 2 minus x, yes, that's fine. But it's, most mathematicians like to put these in decreasing powers of x. So your cubed first, your squared next, your power of 1 next, and then obviously the term with no x's goes last. So again, that's kind of just saying that's the general way. But if you wrote all 4 terms correctly in a scrambled order, it's all good. No love lost. Right, so next up, we got factorize fully. Right, focus on the coefficients first. 10 and 15, 5 is the biggest number, goes into both. C cubed, well, they've both got at least one C, and they've both got at least 2 Ds, so D squared. So these are the common terms. Now, what goes in the bracket? Ask yourself, what would I need to multiply 5D squared to get this number here? Well, I'd have to do 5 times 2 to get my 10. I need 2 more C's, because I'd have to do C times C times C to get C cubed. So that's not just 1 C, but 2. So that's C squared. And D is fine, right? I've got my D squared. There's not a problem there. Cool. Plus, what would I have to multiply 5CD squared again to get 15CD squared? Well, I need 3, because 5 threes are 15. I've already got C, so that bit's fine. But I need a D. I need not just one extra D, but D times D, so D squared. All right. And there we go. We've done it. So the answer is 5CD squared, bracket 2C squared plus 3D squared. Cool. Next up, simplify this. So when we're dividing, I'll deal with the coefficient first. 3/6 is the same as 1/2. The x, think of that as x to the power 1. Divided by x squared, well, you could say that one of the x on the top cancels out with one of the ones on the bottom. So it'll be 1 over x. And then as far as y's go, one of the y's here would cancel out with one of them there, but it would still be y squared. So tidying this up, the numerator would simply be y squared. The denominator would be 2x. That would be the answer, y squared over 2x. Let me just double check the mark scheme here, because you never know. 9A was right, 9 was right, 10 was spot on. Okay, this is going a lot better than last time. Oh, we got a cheeky cumulative frequency now. Remember, cumulative frequency, always the right value is your x-coordinate. So please, 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 please do not do the midpoint. If I got a power for every time I saw that, I could buy myself something very nice. So the first coordinate, and of course, these are all your y coordinates on the right, your cumulative frequencies. So first point, 2013 is what I'm going to plot. 2013, be accurate, obviously, followed by 3036, 3036. Okay, where are we? 4042, 4042. There we go. Is that right? Yeah, we're good. 5047, which is down here. 6052. Here we go. Almost done now. Couple more to go. 7056. Wash. And finally, 8060. Let's go. Okay. Now, looking at this cumulative frequency graph, the smallest number, always look at the very beginning. This sort of number on the left is the first. This is where your graph starts with 0. So for this is like a special coordinate here, because there is no value that's less than 10. So your starting coordinate will be x is 10, y is 0, because obviously no one is younger than 10. So yes, 10, 0. Okay, cool. So the next bit is just to join all dots together. Do not use a ruler. If you use the ruler, You're going to lose marks here. It's a freehand job. So you want a smooth curve, and it must cross. It can wobble, fair enough, but it must cross all points. So it can wobble a little bit on its way to the next point, but it has to cross it. So be really careful. Okay. Release the inner artist. Look at that. Perfect. I should have done GCSE art. Anyway, right, B, use an estimate median. Right, so this continuous data, so we don't have to add one, we just have to halve it, right? Remember, median means the person in the middle. Now, if you've got 60 people, the middle person's the 30th one, right? So you do 60 over 2, 30, your median is going to be 25. 25 years old is the person in the middle. Now, the interquartile range. Now, remember, think, what does quartiles mean? What does that rhyme with? What quarter? Yeah. So, like, rather than median, which focuses on the middle person, the quartiles, you take your total amount, 60, and you divide by 4. So we're counting, instead of counting, we're counting 15s. So basically, look, the 15th person, so on my cumulative frequency, I'm going across and down. He's going to be 20 years old, or she, right? So we call this the lower quartile. Some people call this quartile number 1. And that's 20 years. The second, so we're counting up in 15s. Now the second quartile, Q2, you'll know this as the median. This is literally part B. Was 25 years, right? And the upper quartile, Q3, is going to be, we're counting up in 15s, it's going to be the 45th person. So instead of saying, oh, I just want the middle person, I say, well, let me break into quarters. I want to know, what are the 3 people, the 3 special people that break my data into quarters? And we found them. Granted, one of them is the median. But yeah, the upper quartile is 45-year-old. So the IQR doesn't really need the median. It just needs the upper and lower quartile. So IQR for short is UQ for upper quartile, take away your lower quartile, which we've identified to be 45 take away 20, which is 25. So there is a little bit of wiggle room. Like I said, your lines can wobble a little bit. So if you're sort of, and again, let me check the mark scheme here. They do give you a bit of grace in terms of your lines wobbling. So yeah, the mark scheme, and again, yeah. So me staring at the mark scheme now, it's saying allow anything between 24 to 28. So yeah, because your line wobbling a little bit, it might be slightly out. Yeah. So don't panic if you got 24, 25, 26, 27, or even 28. I could have probably been accurate because my 25 is not in the middle, but it's within range, so all good. Next up, lastly, find your graph to find an estimate of the number of people who are older than 55. So this time round, we're looking at 55 going up and across. If you're really, really careful, there are 49 people that are younger than 55, but there are 60 in total. So let's think about this. Oh, I can't believe my memory's gone already. So yeah, look, 55, there's 49 people are younger than 55. So there was 60 in total, weren't they? Well, out of my 60, if 49 people are younger, that can only mean one thing, that 11 people are older. And again, you are gonna get a bit of grace here. The mark scheme allows 10 or 11. So my 11 is totally fine. All good. Number 12, right. Oof, I got a lot of people asking me about this in the lesson, but yeah. Kidoki. So we got to identify which of those graphs is minus 2x plus 3. Right, firstly, this is a straight line graph, right? Because it follows the order of y equals mx plus c. A negative gradient means your graph goes downwards, right? Because my gradient's negative, it's minus 2, it goes down. If you read left to right, it goes down. And the plus 3 means it crosses at a positive number. So which is a straight line graph that goes downhill, but also crosses at, roughly speaking, 3 on the y-axis? Well, G might have caught your attention, but look, it crosses at a negative. This is below the 0. So it can't be that one, although it does go downhill. It has to be C because this looks like 3. This one looks more like maybe -3, but no good. So remember, that's going to be the first one's graph C. Cool. 1 out of 4. Let's go. Right. Next on the menu, 1 over x. -1 over x, beg your pardon. So you might know the graph y equals 1 over x. We call this the inverse graph, and it looks like this. Now the minus sign reflects it in the x-axis. So it's actually going to look like that because the top half gets reflected and this half gets reflected upwards. So which graph looks like the purple line I just drew? It is graph F. The reason it's not B is because it's not 1 over x, it is -1 over x, so it's F. I bet that probably quite a lot of yous. Tan x, now tan x, you need to know the graph of this. You need to know the graphs for sine, cos, and tan. Now tan kind of looks a bit like a wave, not like a wave, but like sort of like that. And moreover, every at 90 degrees, it has an asymptote, meaning the graph, if you type tan 90, it will say math error. That dotted line basically means you can't do tan 90 because this doesn't exist, right? Or it's not defined. I won't go too far into that, but just know that. So we're looking at this. Yeah, it's graph D, isn't it? Clear as day. There is no other graphs to confuse with there. Now, lastly, now this one's a bit of a sneak face. Graph D. Sorry, we just did graph D. I meant the fourth graph. Now, you could expand this bracket like we did not long ago, right? Remember, when you multiplied out question A, notice how our answer, because of these 3 x's, we got 9x cubed plus blah, 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 plus blah, 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 right? The 9x cubed bit is very important. It's the highest power. And this means that the bottom, this triple bracket here that's sort of what they've been asking us to identify is a cubic of some sorts, right? It's going to be x cubed plus blah, blah, blah. Now, all cubic graphs where the x cubed is positive, here it's +1, if you really want to imagine the number in front of x cubed, it always has this wave. It kind of goes up, down, and up again, right? If it was negative x cubed, it would go downwards, but it doesn't. So positive x cubed. So it looks like a wave. It sort of starts here at the bottom, goes up, comes down a little bit, and back up again. All cubics have this shape. So looking at these, the only one that looks like that is graph H, and we are good to go. Another way you could have... so there was 2 ways you could have got this. So what graph was that? H. So there were a couple ways you could have deduced this. Why is it? All right, H. So that was one way you could have deduced this. Another way, I want to know how many of you thought about this, but you could say, well, when is y 0? When does it cross my y-axis? Well, it crosses when x is -1, +1, and +2. So which of these graphs crosses your your x-axis at -1 here, +1 and 2? Well, look, clearly it's this one, isn't it? Look, there we go. So there were 2 ways you could have got that, but yeah, the correct order is CFDH. It would blow my mind if I got this wrong, but yeah, CFDH is the mark scheme. Number 13. Right, righty ho. Does anybody even say righty ho anymore? Who knows? I do. So we're using algebra to show this. Right. I mean, pretend I always say, show that question, remove this from your mind, right? Forget what even is 0.345 recurring. I don't know. My memory is not very good, and that's going to be to my advantage because I'm going to work it out, right? And if you work it out, there can be no error of doubt that you have shown it. Okay, so I don't know what it is. Whatever I've just covered up, I'm just going to call x. but I know that it is equal to 0.345. Now, because the two dots are not above the 3 and are above the 4, 5, it is only the 4, 5 that repeats itself. So 4, 5, 4, 5, 4, 5, 4, 5 ad infinitum, which is a fancy way of saying forever and ever. Forever, ever, forever, ever. Now, because it repeats every 2 digits, you need to multiply it by 100. The reason you do that, and the reason we are going to work out 100x, because I'm going to times it by 100, is all the digits get shifted 2 places to the left. So this 3 tenths will be shifted twice to the left, so it will be in the tens place value. That 4 will now be 4 ones. That 5 will now be 5 tenths. This 4 will be there. This 5 will be there. This 4 will be here. So on and so forth. And you know what? It is a good sign when the sort of the digits are in the same place value, right? If they're sort of one place out, you probably timed it by the wrong amount, right? So some questions they ask you to times it by 10, 100, sometimes even 1,000 if it's every 3 digits they repeat themselves, but you should have the same digits lining up. And the reason is because when you subtract these, 100x take away 1x is 99x. We're going to take these away, right? Now be really, really careful here. A lot of people think, it's just everything after the decimal point that I have to take away. No. In this case, we do have to start by subtracting 5, take away 3, which is 2. Then the decimal point. Then 4, then 3. Okie dokie. So here we go. We're starting. We're cooking. All right. So x equals 34.2 over 99. Now, I don't like the decimal point being there. A few ways we can get rid of this. Times everything by 10, top and bottom. 342 over 990. I have times both top and bottom by 10. Now I'm going to cancel out. They're both You know what I've just realised? The visibility test for 9. So if you add the digits up, on the top you get 9. And if you add these digits, you get 18. Right, 9 plus 9 plus 0 is 18. And I know that 9 and 18 are both in the 9 times tables, meaning I can divide top and bottom by 9. So let me simplify. 342 divided by 9 is not nice. So how many 9s going to 34? 27, that would be 3. Remainder 7, because 27 plus 7 is 34. And 9 goes into 72 8 times. So 38 on the top. Divide the bottom by 9. This is a little bit easier. 110. Yeah, dividing the bottom by 9 should be quite straightforward. They are both even numbers. So again, we can divide top and bottom by 2. So the bottom's easy. Half of 110 is 55. Use bus stop if you don't believe me. And half of 38 equals 119. 19 over 55. Now, 19 is a prime number, so yeah, we're done here, aren't we? Now, the moment of truth. Let me rub out that green speck at the beginning. If it's 19 over 55, I will be a happy chappy. Right, all good. It was correct. Let's go to 14. Enlargements. Okay. Sorry. Describe the single Right. If any more of you start saying, it's bigger, it's reflected, and we do a rotation. Single. You're only allowed one. Don't mix and match rotations, translations, and all that. You're only allowed one of them. You're only allowed to say one of rotations, which clearly it isn't. Reflection, which again it's not. So don't say any of these. You're only allowed to use one of these. Translation could be, but clearly it's bigger, so no. It's an enlargement. You are not, the moment you say two of these, even if one of them's you've said is enlargement, you get 0. You're only allowed to say one of these 4 words if it says single. Only if it says, let's mix and match, can you do that? So we are going to start by saying it is an enlargement This is a 3 marker, so we've got to say 3 things. Scale factor 3, because the lengths are 3 times bigger. Again, you just have to compare one of the sides to notice that. The last part, and you do need a bit of a ruler here, so I'm going to have to do my best to the nightmare on iPads. This is a lot easier when you're dealing with paper, but you want to do a straight line that goes through all the corresponding vertices. Right. And I think they all meet here, don't they? I'll double check the mark scheme, but that's going to be your centre of enlargement. This is probably the only question I really can't do properly on a iPad, but I think, yeah, I have actually got it right. So enlargement, scale factor 3, centre of enlargement, and then in brackets give you the coordinate 3, 0. So that's for your third mark there. All right, good. On the grid above, translate A, that's the little one, for minus 4, 3. Minus 4, 3. By the way, I would leave those lines in your exam, please. Don't rub them out. I'm just doing this to demonstrate to you the next question. Minus 4, 3 means 4 left. So look, pick that corner there. 1, 2, 3, 4 left. Because the first number is negative. 3 up. 1, 2, 3. So that top left corner is going to go there now. And you can do this for all 3 corners if you want. So 1, 2, 3, 4. 1, 2, 3 goes there. Bottom right corner or vertex. 1, 2, 3, 4. 1, 2, 3. Yeah, look. And that's where your resulting triangle is going to go. Obviously, use a ruler here. I'm on an iPad, which makes it challenging. And that's C. That's C. See you later. Right, number 15. Solve the inequality. Solving inequalities is the same as solving equations. The only rule you're sort of not allowed to break is keep the arrow facing the same way. You're allowed to add, subtract, multiply, and divide. The only rule is if you multiply or divide by a negative, you have to flip the sign to face the other way. That's the only time you flip the sign. Otherwise, if you add or subtract, including negatives, you can keep it the same. Okay, so here's what I'm going to do. So I'm going to add 4x to both sides to begin with. So these cancel out. I've got 3 is less than 11 plus 4x. I'm going to subtract 11 from both sides. So this would be minus 8 is greater than, smaller than 4x. And then I'm going to divide by 4, which is a positive number, so I don't have to change the sign. So x is greater than negative 2 is the answer. Greater than or equal to 2. Negative 2. Let me triple check my mark scheme. Yeah, it's a little bit too easy to get wrong. Spot on. Okie dokie. So, the mark scheme on this one's actually wrong. I know this because I went through this in class. T is a midpoint. Okay, we got a cube of length 6. So we need to know the length from T to V. Now, it says integer. This is a lie. It's actually a surd. I know this because I did this in class. So here's what we're going to do. Here's how we're doing this, people. Imagine, forget it's 3D, but I want to start off by thinking about this blue square I've just drawn. Now, this is going to be a right angle triangle with lengths 3 and 3. So 3 and 3. And the hypotenuse, using Pythagoras theorem, is going to be, we'll call it x, but yeah, x squared is 3 squared plus 3 squared, which x squared makes it 18, sorry, right? 9 plus 9, 18. So x is the square root of 18. Leave it as a surd. Next on the menu, well, look, we know that I'm going to draw this orange line. This is a vertical line from T to sort of halfway between D and C. And to complete this masterpiece, I have been known to be compared to they call me the mathematical Matisse. If you know, you know. It's hard to convey that message on an iPad, but you know, it is what it is. But look, if you see that in 3D space, we've got another right angle triangle. So The purple line is actually the one we want, isn't it? It's T to V. TV is the line we want. And, we already know that the bottom line is root 18, and we know this height is 6 because it's the sort of length of the square, isn't it? So again, we apply, this is another right angle triangle. We apply Pythagoras theorem. So it's going to be this side squared, root 18 squared plus 6 squared equals TC squared. So now the roots cancel out. The root, there's no point in simplifying the third here because it just gives you 18. If you wrote 3 root 2, I mean, you kind of wasted your time a little bit, but whatever. Plus 36 equals TC squared. So let's wrap this up. 18 plus 36 is 54 TC squared. So TC is the square root of 54. This you can simplify the root here, or the third. So this is 9 times 6, isn't it? Which is 3 root 6. If you got 3 root 6, I think root 54 is probably enough to get full marks here. Let me double check the mark scheme. I think the mark scheme, the only confusing thing for 16 is it does say it wants an integer, which doesn't really make sense because, they say root 54. So root 54 is enough for the mark. Obviously, if you simplify the third, they could not penalise you for this because you've actually, you kind of done a surplus of requirements there. All right, here we go. Simplify fully. Simplify fully. All right, okay. There's various ways you could approach this. In my head, I'm thinking, do I flip it first or do I do the -2? You know what? Let's just, this is the same as 1 over, because of the negative. We can write all of this squared. Okay, and this means keep flip change. So when you're dividing by this, you're sort of, keep flipping the fraction 8xy squared over 2x5. But remember, we are raising it squared still. So what we're going to do now is we're going to do 8 squared, x squared, y to the 4. I've basically times all the powers on the numerator, and I need to do the same with the denominator. So this becomes 2 squared, x squared. Hang on a minute. x10. I'm just triple checking that I haven't made any silly mistakes now. I can't see any, so let's crack on. Now, 8 squared is 64, 2 squared is 4. We'll divide that in a minute. 2 of the x's on the numerator cancel out with 2 from the bottom. So x squared divided by 8, the 10. You can write it as x to the -8 in your numerator. Alternatively, you can just say it's 1 over x to the 8. So whether you leave it in your denominator or numerator, obviously depends on whether you want to keep it as a negative or not. And then the y, well, this is the only y left, so it's y to the 4. So last step for me is 64 divided by 4 is, should know this really, shouldn't I? Being a maths teacher and all, but it's 16, isn't it? So look, we've got 16 y4 over x8. I'm pretty good. I'm feeling pretty good about this one. Let me double check. Yeah, we're good. That's the mark. All right. Completing the square now. Keeps asking me about that. Anyway, we move. So, completing the square, always start, forget the 3 for now. Focus on that, right? Bring out 2 as the factor, x squared minus 6x, because obviously that would give you 12x if you times it out, plus 3. Now, completing the square, you always halve the number in front of the x, in this case, minus 6. So in brackets, I'm going to write x minus 3, halve that number, square it, and the reason behind this is if you were to expand the double bracket, you would say, well, actually, these two things are almost identical, right? Look, I've got the x squared. If you do minus 3x and minus 3x, you get minus 6x. Check it out. Look, these two are the same, but then we also have the minus 3 and minus 3 plus 9. I did not want that. This was a surplus, but there's an easy way to fix it. You just say, well, look, they're the same. You just got to remember to take away 9 at the end. So, in my bracket, all of this bit is the same as writing this. So, 2 bracket, let's be careful here, x minus 3 squared minus 9 plus your 3 at the end. And all that's left now is tidy up. So 2 times that bracket there. So 2 bracket x minus 3 squared. 2 times negative 9 minus 18 plus 3. The last final move you've got to do is just to do minus 18 plus 3, which equates to minus 15. So there it is. So A is 2. B is a negative 3. So look, just looking at how they formatted it, so that's your A. A is 2. B is a negative, which I know the bit that throws people off is that, why does it say plus B? Well, you can add a negative. There's nothing wrong with that. And C is also a negative. So these are your 3 values for A, B, and C. Let me confirm. I can confirm I am correct. Let's plow on. All right, 19. Not for the weak. All right, what we got here? We got f(gx) is greater than 0. So composite or compound functions, you always read right to left. G of x goes into f. So I'm going to put all of this into there. Right, g is going into f, not the other way around. So g going into f means 2x plus 1 is going into my x squared minus 4. Okay, this is f(gx). So let's expand this out. You get 4x squared plus 4x plus 1. Take away 4. Okay. Just making sure I've not made any mistakes, but I don't think so. So far, we are good. So let's tidy up a little bit. Your 1 and your minus 4 give you negative 3. And remember that that is equal to greater than 0. Sorry, not equal, greater than 0. Okay, so we've got a quadratic, but a, the number in front of x squared, is not 1. We're going to use the AC method. So we want 2 numbers that multiply to whatever AC is. So AC, A times C, 4 times negative 3 is minus 12. So I want 2 numbers that multiply to give negative 12, but also add to give B 4. So that's going to be 6 and 2, isn't it, right? So those 2 numbers that times negative 12 are going to be positive 6 and negative 2. So unlike unlike when x squared, I know you do something similar for x squared. This doesn't mean these are the numbers that are going to bracket. It means we're going to split 4x into 6x and minus 2x, right? So the 6 and 2 help you split the middle term, if you will, into 2 bigger parts. And you're probably wondering, what's going on here? Why do I want more terms? Why do I want more terms? I thought the whole point was to sort of simplify. So bear with. There's a method to my madness. The reason you split it up is if you factorize your first 2 pairs, right? So instead of factorizing the whole shebang into double brackets, just focus on the first pair. What is common about both of those two, 4x squared and 6x? Well, they're both in the 2 times tables, and they've both got an x. And inside the bracket, I'm going to do 2x plus 3. Fair enough. And I'm going to do the same with the second pair of brackets. I'm going to do an orange. Now, here, you're probably thinking, there's nothing that goes into both of these, and you're kind of right. But I'm going to bring out minus 1. Minus 1 is a common factor. The reason I do this is because inside the bracket, I get 2x plus 3 again. Now, if you only brought out plus 1, you'd get minus 2x minus 2 in the brackets, and the brackets would line up. That's why I'm doing the minus 1, greater than 0. Now, if you look at both of these, they've both got the same brackets. So we know when we factorize the bracket, we'll have the second bracket will be 2x plus 3, but the first bracket will be the thing in front of each one. So it'll be 2x minus 1. Bam. First bracket. Done. Now, if we were solving a quadratic equation, we would say, well, look, either bracket has to be 0. So here, x is a half, positive a half, but in this second one, x would be minus 3 over 2, or minus 3 halves. And I'm just double checking. I don't think, yeah. So again, this is not an equation. If it was equal 0, you'd be happy days. You'd be able to go home and all that good stuff. But it's an inequality. And in order to solve this inequality, I'm going to need you to pull together and try and graph this function, right? So what would y equals this look like? Well, it would be a quadratic, so it's a U-shape, classic U-shape. But my classic U-shape crosses the x-axis at these two coordinates, meaning it crosses at minus 3 over 2. This bit does not have to be accurate, but and a half. And it'd be this classic U-shape we know and love. Don't worry about where it crosses the y-axis. It's not necessary here. But you get what I'm saying. And what we want to know is, when is this graph greater than 0? Well, it's greater than 0 here and here. Right? Now, these values of x are all less than minus 1.5. And all of these values are bigger than a half for x. This is an inequality. We only have to involve x here. No y is allowed at this point. This graph is over the x-axis, meaning it's greater than 0 when x is less than 3 halves. It can't be 3 halves exactly, because then it'd be equal to 0. We want it to be bigger than. So my inequality will be x is strictly less than minus 1.5, or you can write that as 3 halves if you did that. Minus 3 halves, sorry. Let's keep it as a fraction. Let's not confuse you anymore. So x is less than minus 3 over 2, comma, x is greater than 1 half. You must write both. If you only do one, you're not getting full marks, okay? So, right, we're going to go, is this the last question? Are we done? We got a couple more to go. No, we got a fair few. Crikey, this is a long one. So, solve simultaneous equations. Do you know what? I'm going to start by making x the subject. Unfortunately, this is non-linear, right? The x squared means you can't just eliminate, you can't sort of multiply one and take away. That's not going to work when you got x squared, right? It's just not going to happen. So here's what you do. We're going to make x the subject in the first one. So this is now going to be x equals 2y plus 3. And anywhere in the second line where I see x, I'm going to change it to this, 2y plus 3. We call this solving simultaneous equations by substitution. And it's the only way you can do this. So look, that x, change it to that, right? We're going to replace all of it with 2y plus 3, but we also need a square, right? It's not just x, it's x squared. Minus y squared. Y squared stays, right? And again, we've got a 2x at the end, so 2 lots of this bracket. You will need brackets here, 2y plus 3. All equals 10. Okie dokie. So we need to solve this, right? This is kind of similar to 19, to be fair. So let me expand the double bracket. So I'm going to skip this bit here. 4y squared plus 12y plus 9. If you don't know why, do the working out yourself, because I want to speed things along. The minus y squared we leave alone. And we'll expand the bracket out. 4y plus 6 equals 10. Fair enough, right? Now, any quadratic, we always want to make it equal to 0. So we'll move the 10 over. So this is going to be minus 10, because we want it to equal 0. You know what? Let's just write it all again, right? Why not? I don't want to leave anything for the chance when it comes to me communicating with the examiner. Okay, let's tidy up. So, first of all, that's the only y squared term. 4y squared stays. Let me deal with the y term. So I've got 12y, 4y. We're adding them, 16y. Nice. And then we deal with the numbers. I'll do this in red. So my 9. I've just realised something I'm going to go back to in a minute. 9, 6, and 10. 9 plus 6 is 15. 15 take away 10 is 5. Now, I did miss something. Eagle-eyed viewers will have realised, and this is why I like to underline it, I forgot to take away the y squared from the 4y squared at the beginning. So you know what? It should have actually read 3y squared. If you spotted that, yeah, because my 4y squared take away my y squared. It's handy to underline because then you don't skip anything. But again, don't worry too much. Equals 0, right? Cool. I'm going to do the AC method again, like I did in the previous question. So A and C are 3 and 5. AC is 15. So I want any two numbers that multiply to 15 and add to give the middle term 16. It's going to be 15 and 1. Yeah? They're the only pair that times to give 15 add to give 1. So when it comes to splitting up my middle term, 15y plus 1y goes there. Okay, we've got my 3y squared at the front, my 5 at the end equals 0. Factorize your first pair. So 3y is the common to both, and it'll be y plus 5. Then factorize this. Now, if they haven't got any common factors, bring a 1 out. Bracket y plus 5 again. At this point, if your brackets aren't identical, you messed up. Go back and fix it. But for me, happy days, y plus 5 is common. And obviously what goes in the first bracket are these two things, 3y plus 1. 3y plus 1, bam. Equals 0. So I've now got two solutions for y. Either this equation equals 0, so 3y plus 1 equals 0. Y has to be minus 1/3. So y could, and there's going to be sort of, this is where you don't want to mess up. So one of my solutions is minus 1/3. This one's a little bit more easier going. Y is negative 5. So y can be two possible values here. Now, we're almost done here. We did the hard bit. We did the hard graft. But we also remember that for this equation is going to be really useful because we also have to work out x. And there'll be two separate versions of x we need to calculate depending on which value of y we're going to do. So when y is minus 1/3, x would be 2 lots of that. So 2 lots of y. I'm replacing y with minus 1/3 plus 3. So minus 2/3 plus 3, which 3 is, again, you can think of 3 as 9/3. So it's a tricky way of writing 3, but the reason I do this is because 9 take away 2 is 7/3, isn't it? So that's my first pair of solutions. And the other one's a bit easier. So again, same formula. X is 2 lots of y. So 2 lots of negative 5, add 3, minus 10 of 3 is negative 7. So we've got a pair of solutions. We've got either x is 7/3 when y is negative 1/3, or x is negative 7 when y is negative 5. Is that, please, such a pain, these questions. So let me confer, let me get a VAR check with my mark scheme, and VAR complete. We are good to go. Right, 21. Oh, this is a naughty one. All right. There are some tricks of the trade you can do here if you pick up on the hints. So, there are various ways you can do it. To make my life easier, let's think about what's inside the bracket. Now, I know that this is the difference of two squares. So, difference of two squares, when you've got an x squared, take away a squared number like 36, you can just write x plus the square root of 36, 6, and then x minus the square root of 6, which is the takeaway 6. Why write it like that, you ask? Well, have you noticed that this one has a denominator of minus 6 as well? Right? Why is that useful? Well, if I multiply this fraction, the second one, if I multiply this, top and bottom, of course, by x plus 6, they will have a common denominator. So let's do that. So this will now be, well, you know what? I'm not even going to expand the bottom bracket. It'll be x minus 6, x plus 6, which now means the denominators are identical. And the top, the numerator, will be 2x plus 12. So think about it. Inside this big bracket, I'll have 20, take away x plus 6, x minus 6, minus 2x plus 12. But that now has the same denominator, times 1 over 4 minus x. Okay, so because I have a common denominator now, I can bring them all under one happy family. That happy family being x plus 6, x minus 6. And then I do 20, 20 take away 12, which is 8. Now this bit, be careful. Yeah, a lot of people forget. A lot of people think you're only taking away 2x. You're actually, where the minus sign's been written, you're taking away both the 2x and the 12. So 20 take away 12 is 8. That's where my 8's coming from. And then obviously take away 2x, you've got minus 2x at the end, times 1 minus 4 take away x. Now, I'm going to factorize the numerator. So this, because they're both even, I'm going to write as 2 bracket 4 minus x. And I wonder if you noticed something. And if you said, yeah, I noticed something, I noticed that the we see a 4 minus x twice. So we can cancel out the 4, take away x. Nice. So we're almost done now. We are wrapping up. The answer is going to be 2 over x plus 6, x minus 6. Now, whether or not they accept this, or, you can leave it as x squared minus 36. I'm sure they'd have to accept both, because you'd argue that factorized or expanded are both adequate ways of simplifying. But yes, var check complete. This is the one in the mark scheme, but again, if you left it like that, you just factorized it. Yeah, the mark scheme actually has both, so we're good. 22. This is actually not that bad. So look, all right, 2 and 4, let's rewrite everything in powers of 2. So 2 over k, 4 is 2 squared to the power of n. All I've done there is I've just replaced 4 with 2 squared, which is, I'm well within my rights. So 2 to the k over, now to get rid of the brackets on the denominator, you can multiply them out. 2 to the 2n equals 2 to the x. Now when you divide powers, you can you take them away usually. So this bit on the left becomes 2 to the k minus 2n equals 2 to the x. And look, both are basically 2's to the raised to powers. This and this have to be equal now. So x equals k minus 2n. So final expression, yeah, that's it. X in terms of k and n means x is a subject. Always read the question, because it could have easily asked for k to be the subject. But we are good, and that's what the mark scheme says. Okay. So this one's transformation of graphs. Minus 3 means you move down, the graph moves down by 3 units. So it means all your y coordinates have 3 subtracted to it. I got 10%. I can do it. I'm feeling brave, right? So that means move your coordinates 3 units down on the y. So the minus 3 stays the same, but your y coordinate is now going to be negative 1. Just like this one. I mean, look, if you're getting 1 right, you're going to get part 2 right, because obviously this means original graph goes up 5 units. It's the same thing, but just the opposite direction. So it'll be minus 3 plus 7. Lastly, here's a graph. Okay, be really, really careful here. Like BidMass, transformation of graphs, here we've got two things to deal with. We've got the minus C, we've got the minus G. Which one do you do first? Right. Always say minus C means you're going to move it right by C units, right? So if I was drawing the graph y equals G of x minus C, I would say, well, that just means I'm transforming it by moving it to the right by C units, right? Every x coordinate would shift right by C units. Now, the negative at the front usually means all the y coordinates get reflected. So it is a reflection in the y-axis. So, sorry, just to backtrack a little bit there, because remember, we are following that coordinate B, aren't we? So on the orange one, where we only took away C, the coordinate for that exact point would be P plus C for the x coordinate, followed by Q, right? Because it's only the x coordinate that's been shifted to the right. All the y coordinates sort of stay put. And then secondly, the minus means you reflect it. So it would look like this, wouldn't it? So the x coordinate actually is just as far right as it was before it got reflected. So P plus C is still the x coordinate, but obviously all the y coordinates get sort of negated. So it'd be minus Q here. So find the coordinates of the image of the point B. So it'll be, I think it wants in algebraic terms, P plus C for your x coordinate, or C plus P. You can rearrange the order, but then negative Q for the y, which is var check complete. I've checked my mark scheme. Okay, 24. All right, okay. Now, before we rationalize the denominator, let's just deal with squaring it out first. No point in timesing it by root 2 plus 1, because with that power, there might be problems. So the first things first, what's root 2? Take away 1 squared. So root 2 minus 1, root 2 minus 1. You've got root 2, which is 2. Root 2 minus 1 minus root 2. Then you've got another minus root 2. And then you've got a plus 1 at the end. Okay, cool. So you're going to get 3, because of your 2 plus 1, minus 2 lots of root 2. So the first step is by just saying, well, this actually is 3 plus root 8 all divided by 3 minus 2 root 2. We have dealt with the squared term. And again, this is a non-calculator paper, so I am not relying on that to check my answers. I'm pretty confident, yeah? So far, so good. Now, we need to multiply this by, when you've got a plus or minus on the rational denominator, you do 3, there's still 3 and 2 root 2, but we're going to add instead. So we need to do 3 plus 2 root 2 on the top and bottom. So we'll do the denominator first, because we do want to eliminate the square root on the bottom. So you've got 3 minus 2 root 2, 3 plus 2 root 2. So double brackets, 3 threes are 9. That is plus 6 root 2. This is minus 6 root 2. And the last one, this is a tricky one, minus 2 twos are 4. But then root 2 times root 2 is 2. Your 6 and minus root 2's cancel out. 4 twos are 8, so minus 8. So this is nice. It gives you 1. 1 is on the denominator. That's nice. There is no fractions anymore. So actually, all we got to do now is deal with the top, which is 3 plus root 8 on the numerator. But we also had to times it by 3 plus 2 root 2. So let's multiply that out. 3 times 3, 9. 3 times 2 root 2 plus 6 root 2. Root 8 times 3 plus 3 root 8 times these two to finish with, plus 2 lots. Root 8 times root 2 is root 16. Okay. We can do a bit tidier now. So you'll notice that I'm going to simplify this third. So this is the same as writing 3 root 4 root 2, because you'll see why in a minute. Actually, you know what? No, I'm going to show you now. The reason I've did 3 root 4 root 2 for this expression above is, well, root 4 is 2. So this becomes 3 times 2 root 2. We'll come to that in a minute. Plus, well, this is 2 lots of root 16. Now, root 16 is simply 4. So new line of working, 9 plus 6 root 2, plus that, plus 8 at the end. So 3 lots of 2, 6 root 2 plus 8. Okay, almost done now. 9 and 8, 17. 6 root 2 and 6 root 2 is plus 12 root 2. So that's my answer. The answer was P plus root Q. Here's your value of P. P is 17. Oh, okay. It wants it to be a third. Now, I simplified it, which isn't what they wanted. So how can I make sure that 12 root 2, because I might lose marks for not giving it the way they wanted, despite not being wrong, how can I put this all under just one happy family square root? And the trick is this. Think about what 12 squared is. 12 squared is 144. So 12 is just the square root of 144. Why do this, you ask? Well, look, by turning 12 into root 144, we can now times them together. So root 144 times root 2, root 288. So it's all under one happy family. So it's 17, root 288. Yeah, most of the time they want you to simplify the third. So I defaulted to sort of 99% of the time when they say, right, leaving the form P plus Q root 2, but they've insisted in your question they want this to be under one single square root. So P is 17 still. That bit was fine. Q is 288. So be wary. I would predict a lot of you wrote 17 plus 12 root 2, which is not incorrect in terms of the equation itself, but you know, write in the format they asked for. Okay, I got 7%. I can do this. Kiara throws 4 fair 6-sided die. Okay. I'm thinking of the most efficient way. Work out the probability that at least one of these dice lands on an even number. Now, there are various ways, some more difficult than others. I can rephrase the question. Rather than saying the probability that at least one of the dice lands on an even number, it's the same as saying, what's the probability of it not landing on all odd numbers? Basically, you're going to get at least an even number as long as all 4 throws. Basically, if you throw 4 odd numbers, you lose. So basically, anything goes except for you getting 4 odds in a row. You would lose. Okay? Because anything that's not 4 odds in a row is at least one even number. So let's see, what is the probability of getting 4 odd numbers in a row? Well, this is a normal dice. I'm assuming it's fair. Yes, it says that in the question. Well, 3 and 6 numbers are odd, right? 1, 3, and 5, right? You've got a 3 and 6 chance. Actually, let me get to the work in a bit. So the examiner might want to see the probability of getting an odd on any given throw is 3 and 6, which is a half, right? Cool. Kind of makes sense, right? Half the numbers on the dice are odd. So you getting 4 odds in a row is, well, because they're independent events, we can multiply them, right? So 4 odd numbers in a row, probability of 4 odds in a row, is going to be a half times a half times a half times a half, right? 1 times 1 times 1 times 1 times 1 is 1. 2 times 2 times 2 times 2, 2 to the power of 4 is 16. There is a 1 in 16 chance you get 4 odds in a row. So if you did this experiment where you threw for all dice, if you did that 16 times, one of them you'd expect to get all 4 numbers. Roughly speaking, obviously there's an element of randomness. So the probability of getting at least 1 even is equal to, well, look, you're certain you're almost certain that you'll get at least 1 even. Take away the probability you get 4 odds in a row. So it's 1 take away 1/16, which, I mean, this is easy maths now at this stage. 16, well, 1 is the same as 16 over 16. Take away 1/16, the answer is going to be 15 in 16 chance. Okay, let me get a bar check. Yeah, there's various ways you could have done this. So if you got 15 out of 16 at the end, there are other ways, but there we go. All right, well done for tuning in, and mark schemes are coming in just a sec. Okay, right, here's mark schemes, so you know what to do. I will scroll slowly, and you pause whenever you need to. Right, that's it from me. Catch you in the next one.